hello, and welcome to the show. It's me, John Park. It's time for JP's product pick of the week. Thanks so much for stopping by to you all. We have chats over in our YouTube as well as on our Discord server. So if you're looking for the chat, those are some places to go. If you go to adafruit.it/discord, you can look for this live broadcast chat channel. Right there, that one there. And I'll say hello to Jim Hendrickson and Thin Man, Blitzity DIY, Paul Cutler, hello, C. Grover, thanks for stopping by. Hey, John Nodge, welcome. And over in our YouTube, we've got Dave Odessa and David Bronke, Quinman16, and Dia Eldin Mustafa, hello, thank you for popping on by to the chat today. So what is this? Well, we've got a new product pick for you this week. It is right there. If you want to go check it out, head to that URL or head to that QR code, depending on what sort of gizmos you use. And you will find that we've got this show broadcasting from inside the product page. We have the product on discount, 50% off this fine day, or actually just during this show, so for the next half hour or so. You don't need a coupon code or anything. You just throw it in your cart and get it for that listed half off price. We have 100 in stock at least. We stashed 100 before the show. Thank you to New Products team for putting all that together. And then the price will go back up right around the end of the show, a little bit after the show completes. So go check it out if you want. Before I say any more, I like to have Lady Ada tell you all about it from her new product segment. Take it away, Lady Ada.
Dun, dun, dun. It's the VCNL 4200. We did like videos and I released a breakup for the VCNL 4020, and then like one day I typoed it and I accidentally went to the 4200 page. I was like, oh, this is kind of a cool sensor too. So this is a long range infrared distance sensor. So, you know, in general, when we talk about long range sensing, we usually tell people get a time of flight sensor. And we stock a ton of those, like the VL53, 51, 54, whatever, all of those in the TMF series. Those TMF flight sensors are super great at everything. They can go multiple meters, but they're a little bit more expensive. Also, sometimes maybe you don't want a laser for some reason. These sensors, you know, this is, the data sheet says they'll go to 1.5 meters. I think that's very optimistic. I think 1 meter is a very reasonable thing to assume. You don't get the true distance output, you just get like a number that gives you like the amount of light that bounced back. But still, like, it's much less expensive. Maybe if you are in a situation where you can't use a laser, but infrared light is okay, then the VCNL 4200 is great. It's also got a light sensor built in. So I've got like a quick demo over here. So let's see, you can actually see the IR light blasting out of here. So this is, it's got the light sensor, so as I cover it, you see the ALS, the ambient, the ambient light sensor goes down to like close to 0, and the proximity goes up to the top. And then as my hand goes up, this is about like, you know, as you get higher, the numbers don't change as quickly, but this is, you know, it's good for like basic distance proximity sensing without giving you the true millimeter output. I think they'll still be useful for some people. So you have it in the store now, check it out, especially if you need a light sensor and you don't want to spend like 15 bucks, then this is a great alternative for infrared distance sensing.
Whoa, hey, music. Yes, it is. That is my product pick of the week this week. It is the VCNL 4200 IR proximity, distance, and ambient light sensor with STEMMA QT. It is a nice little plug and play, no soldering required. You can do it if you want. We've got pins on there. But you can just use a STEMMA QT/quick cable, plug it in, use it in CircuitPython, use it in Arduino. You could use it with Blinka if you had things hooked up that way on your computer. And you can get distance measurements, or rather proximity, more than a measurement. It's just, hey, is something there? And yeah, it'll tell you some numbers for varying distances, but it's good for a couple feet, 3 feet away, up to just right up close on it. I'll show you in practice what that looks like with a little demo I put together. And you also have an ambient light sensor on this. So These are great for just knowing, hey, is something close or getting closer? If you want to use it to trigger effects, if you want to use it, these are often built into parking space meters in garages, into hand towel dispensers and soap dispensers in lavatories. I think similar sensors are used in some devices like phones to tell, have you put it up next to your face or not? And it can tell you both the ambient light and the IR reflected distance. So you can also use the two of those together for certain applications if you want. Very easy to use. I'll show you a demo of what that looks like in CircuitPython to ask for that, that info. But first of all, let's take a look at the product page for it. So there it is. It's product ID 6064. Nice little STEMMA QT board type of package that we have there. You've got STEMMA QT in and out, so you can chain this with other things, plug it into your favorite little microcontroller board if you like. And you can see the package on there is this little, I can zoom in a little closer there, you can see is this little sender receiver. So it's an infrared transmitter and infrared receiver package there, which also has the ambient light sensing built in. On the back side of the board, you've got a LED that is a power LED on the front that you can see, and that, I'll show you in the demo here, will light up green when it's got power. If you had a reason to cut that, then you can, I think, bridge this. I don't think this is a cuttable one. I think you can bridge this set of pads here and it'll shut off that LED. So if you scroll down, take a look here. Look, there's this show right there running in the page. You'll see we've got a link here to Liz's guide, primary guide on the VCNL 4200. Check that out here. We've got an overview of the board. You can see that little demo like Lady Ada showed. Some pinout information on the next page here. So this uses I2C, which means we've got power, ground, data, and clock for your I2C info flowing back to your board. And you can also use an interrupt pin if you need that for your particular application. It says here the LED jumper on the back of the board. It's a jumper for power LED. It's labeled LED on the board silk if you want to disable it. Oh, it says cut the trace. Okay, I guess there's a trace under the silk that I didn't see there. And then we've got some example wiring and code for setting that up both in CircuitPython and in Arduino right there. And if you take a look at the downloads page here, you can check out the schematic for it as well as the data sheet. So here's the data sheet from Vishay. Zoom in here a little bit. You can see the applications they mention here: presence detection to activate displays in printers, copiers, home appliances, collision detection in robots and toys, proximity sensing and light control in offices, corridors, public buildings, parking space availability, proximity detection in lavatory applications, and then you get info about the different ranges. This does allow you in the driver for Arduino and the library in CircuitPython to adjust the power that you're using to send, so that can give you a more accurate reading. You can also increase the poll rate of checking the sensor, or you can go lower power if your application is running on battery maybe and you want to use it in a lower power mode. You have some options there for how much power you're sending to the LED. So let's have a look at this in practice right here. So you can see I've got a feather board with a little matrix LED display on it, and I've got the VCNL 4200 and the infrared receiver transmitter there. You can see as I get my hand closer, I'm just lighting up a little sort of bar graph on my display there. It's kind of bright. I don't know if this will help to diffuse this. Yeah, I don't like the way that looks on camera. It gets kind of flickery. So you can see there we're measuring a certain range, which I'm translating into this presence detection. But this is a pretty close range. If I want to go and change this, let's have a look at the code here. We've got one driver or library to bring in, the Adafruit VCNL 4200. And then we can use the sensor over I2C just by specifying this right here. The sensor is that on I2C. And I am setting my current to the highest, which is this number 7, which equates to 200 milliamps. So that's the highest current you can send to it. You can adjust that with these different steps, these different ranges. And then this is the integration time here. So I have mine set on 3, so it's taking 6 milliseconds. The longer you take, the more accurate it's going to be, but obviously you're going to be eating up some cycles of time there to read that. Then I'm setting up my display, and right now I'm setting my proximity detection from 1, basically as far away as it's going to check, to 500, which is about an inch or so away. And if I turn my sensor here, you can see, can you see me? Let me point it at me there, try to get everything in camera. So in fact, I'll use something, let me see if I can grab something a little more reflective. I'm just going to grab a piece of paper here just so that we get the best readings for the demos we can. So see that proximity value there, streaming 1, 2, 3, 4, 5, 6. So I'm kind of far away for this camera to see. I'm also not yet in that range that you were seeing before. So this won't trigger until it gets high enough to be a 16th of that, since I have 16 rows of these lighting up. And there you can see the values going up and up and up and up and up. And they have sort of a non-linear response. They kind of ramp up exponentially as you get from like 3 inches to 2 inches to 1 inch. You'll see the values really jump up there. You can also see my light values. I'm actually covering, even though this is a white piece of paper, it's covering some of the ambient light. If I just take my hand and put it over there, you can see I'm able to get the light, ambient light value or lux reading down closer to 0. Or if I take something like the light on my camera here, LED, you can see we're measuring much, much higher values there, 30,000 whatever values. I don't think that's lux. Is it? Could be. And that's independent of the proximity, as you can see here. Okay, so let me shut off that, that light so it's not lit up in my pocket all day. And I can adjust these values. So as you saw, my proximity reading, I'm getting from about 4 inches away to about 2 inches away to fill that bar. I have this set up to just adjust the range that I'm going to trigger with. So if we set this to, let's say, 40, no, not 401, 40 to 200, and resave that. That's just going to run immediately, and now you'll see we have just a tighter little range there that's not quite as close that I'm using. So it can really vary what you're doing with proximity, but as you can see, the values are still being printed out there. So if I wanted to trigger stuff when we got about this far away, then I would say if the proximity gets to, let's say, 3, then go ahead and dispense the paper towel or whatever it is. The way that you ask for those values is really simple. In the main loop here, I've got proximity equals sensor.proximity and ambient light equals sensor.lux. Those are the two things to ask for. And then I have a little function here to turn that proximity value into the LED on the display for lighting it up. There was a question in the chat. C. Grover said, is it useful for window raindrop detection, I wonder? I wondered something similar. I was going to look into using it for a water depth gauge, and it does not seem to work that well, at least in my application, because the infrared light, I think, is not bouncing consistently directly back off of the water surface. It's probably transmissive enough that it's sort of scattering the light. So a time of flight sensor might be better for the application I'm looking at. Not sure about for raindrop detection. That's a good question. Let's see. So that is the little demo I have there running inside a CircuitPython. You can do, like I said, in Arduino if you want. Here are a couple of nice close-up photos that you can see there of the little package itself, the little purple lights on there. This overhead camera that I'm using has a IR filter on it, so we don't get to see the little purpley light lighting up, but you will with some webcams, older webcams. And let's see. I think that covers what I wanted to show. Let me know if there's any other questions over in the chat before we wrap that up. And I'll go back to this view of the world. And there it is. So that right there is my product pick of the week this week. It is the VCNL 4200 IR long range distance and ambient light sensor with STEMMA QT. For Adafruit Industries, I'm John Park. This has been JP's product pick of the week, and I will see you next time. Bye-bye.